In this video, we're going to look at trinomials of the form ax squared plus bx plus c, where a is not equal to 1. So we're looking at coefficients of the x squared that are greater than 1 or less than 1, positive or negative coefficients. I'm going to look at many different ways on how we can factor it, but then I will focus on one way factoring it within this video. So when we look at this factoring, let's look at a few problems here today. If I have 6x squared plus 17x plus 7, the first and foremost what I should do is look for the greatest common factor. So when I look at the 6x squared, the 17x, and 7, the only common factor they have is 1, so we can't pull out any factor in this polynomial. So in this method, I will take the a and the c and I will multiply them together. So I call this the AC method. 6 times 7 is 42. So now what I want to do is I want to look for two numbers, and we'll multiply up to 42, and again we'll add up to this 17. That's the coefficient of the x term. And let's go ahead and take a look at some. Again, this is a positive 42, so they either have to be two negatives or two positives. And since the 17 is positive, of course they need to be two positive numbers. Let's go through the list of them. So we have 1 and 42. There's 2 and 21. I see that's 3 and 14. We can stop there, can't we? Because 3 plus 14 is equal to 17. So these are my two numbers that I want to work with in this problem. Now one way in which you can do this, and you say this is equal to, and we set up two binomials here, because the product of these two binomials will be this trinomial up top. Since this is an x squared in front, these will both be x squareds. I'm going to leave some space just for some coefficients. Since this is a 7, only factors of 7 are 7 and 1, so I know one of them will be a plus 1, the other one will be a plus 7. And if I look at the outside terms and the inside terms, one of them must multiply up to 14. Of course, 7 goes into 14, so the outside terms will multiply up to 14. But yet the inside terms will multiply up to 3. So when I look at it this way, I see the 3 for the green here. 1 times 3 is equal to 3. And 7 times 2 would be the 14. So here we have 2x plus 1 times 3x plus 7. So here we're going to check our work here. So 2x times 3x is 6x squared. 2x times 7 is 14x. And 1 times 3x is 3x. 14x plus 3x is 17x. And then 1 times 7 is 7. So we know this is our answer. This is how we can factor this trinomial. Now another way that you can do this, you have to be careful with this technique, because if you do not factor out the GCF at the very beginning, this technique can cause problems for you. Whereas in this previous problem I just did, if you didn't factor the GCF right away, you'll see there's a GCF in one of the terms you can factor out later on. But this is how this other technique goes. You'll do the same process. You'll go 6 times 7, which is 42, and you'll find that 3 times 14 is 42 and adds up to the 17. So what you can do is you can go x plus 3. So I'm going to grab that 3 and put it in here, and x plus 14 to work with this. Now, of course, this is not the answers. If I checked it as x times x is x squared, not 6x squared, and 3 times 14 is 42, not this 7. So, of course, this is not the factorization of this polynomial. But what you do next in this method, this algorithm, is this. Take the 6 in front and divide each of these terms by the 6. Now, when you work with this, 3 divided by 6 is 1/2, so we have x plus 1/2. Go ahead and reduce these fractions as much as possible. And 14 and 6, well, 2 goes into both of those. 2 goes into 14 7 times, goes into 6 3 times. Now, if you're left with fractions in here, we're going to get rid of those fractions by grabbing this 2 and placing it in front of the x, and grabbing this 3 and placing it in front of that x. So you'll get 2x plus 1 times 3x plus 7. So as you see, this is the same answer as we obtained up above. So there are different methods on how to factor these things. You can use any method you want, but make sure you use it correctly. Well, I'm going to do the second method amongst a lot of these problems. But again, I'm going to look for the GCF in each of these terms. So this next trinomial, I'm going to look at these three terms and see what is the GCF of those. And the GCF again for this one is 1, so I don't have to pull anything out. And so now I can use this AC method once again to work with this. 10 times 3 is 30. What two numbers will multiply up to 30 and add up to this negative 11? Now remember, it's a negative 11. Let's see, I believe it's what, negative 6 and negative 5. And so using that second method with this one, we go x minus 6 times x minus 5. Look at the coefficient here. The coefficient here is 10. So I'll divide each of those terms by 10. I'll reduce these fractions here. 2 goes into 6 3 times, goes into 10 5 times. 2 goes into both. And then 5 goes into 5 and 10, goes into 5 one time, goes into 10 twice. And again, with these denominators, make them the coefficients of the x's. We have 5x minus 3 times 2x minus 1. Again, you can check your work, 5x times 2x. Well, actually, I used the wrong variable in here. I used an x since we're common with x's, but it should have been a y, correct? So I checked my work. Good to check your work just to make sure things follow out. Okay, so 5y times 2y is 10y squared, and then a negative 5y minus 6y is a negative 11y, and a negative 3 times negative 1 is a positive 3. So good, this is my answer. Now remember, as I said in a previous video, the order of this doesn't matter. If you put 2y minus 1 times 5y minus 3, it's still the same answer. Okay, they're both correct answers. Now let's go to a couple more problems. How about number 3? 3 here we have 15a squared plus 20a minus 75. So again, the first thing I'm going to do is what's the GCF of this? And as we see, they all have a factor of 5. So let's go ahead and factor out a 5 first. So if I factor out a 5 out of here, we'll get 3a squared plus 4a minus 15, right? 5 goes into 75 15 times. So now I want to see if I can factor this trinomial any further. So we have 3 times negative 15, which is negative 45. Okay, since this is negative, one has to be positive, one has to be negative. And so are there two factors that will multiply up to negative 45 and add up to this 4 that's in the middle? We can try a few. Well, let's just go through the list. Since this is a positive 4, the larger number should be positive. So 45 and 1. 2 doesn't go into it, but 3 does. So let's see, 15 and negative 3 doesn't add up to 4. Let's see, 4 doesn't go into it. How about 5? 5 and 9, right? So 9 and negative 5. And oh, look, that's our pair of numbers. Now, if you go through the list and you don't find any pairs of numbers, that means this is a prime trinomial. It cannot be factored any further. But since these are our two numbers here, I'll go x plus 9, x minus 5. Take the coefficient of the a squared. Again, this is not x. I'm so used to x. I got to break that habit as well. But this is an a. But the coefficient of the a squared is 3, so I'll divide these by 3. Let's see, 3 goes into 9 3 times evenly. And 3 and 5 reduces down to 5/3. Now if it's a whole number, we're going to keep it the same. There's going to be no coefficient of the a other than 1. But again, this 3 I put in front of the a as such. And so my answer overall, also don't forget this 5. That we factor at the very beginning. So this would be 5 times a plus 3 times 3a minus 5. And that's our answer for number 3. Number 4 you can try on your own right now and pause the video and come back and see if you get the same answer. But I'm going to continue here. So here we have 5y cubed minus 21y squared plus 18y. So the first thing you should do is, again, find the greatest common factor. And for 5y cubed, 21y squared, and 18y, what I see is there's a y as a factor. So let's factor out a y out of this term. It's 18, by the way. And so now I'll use the AC method, take the 5 and the 18 and multiply those two together. What's 18 times 5? What's that? 90. And what two numbers will multiply up to 90 and add up this negative 21 inside? So again, both have to be negative for this to work. And I'll just go with the long route. Look at all the factors of 90. 45 and 2. 30 and 3. See, does 4 go into it? No, it doesn't. How about 5? Well, we saw 5 does. 18 and 5. 6 does, right? Yeah, I'm looking for negative 21. That was negative 23. See, 6 goes into it 15 times. And negative 15 and negative 6, as we see, is this negative 21. So using that method we did all along here. Again, there's other methods that you can use within here. Again, grab the coefficient of the y squared and the factored form here. Divide both terms by 5. See, 15 divided by 5 is 3. And 6 over 5 is already reduced, so now I'll just bring that 5 in front of the y. And this is our factored form. Again, don't forget to bring down this y that we factored earlier on. We can check our work. Let's see, what's y times 5y? That's 5y squared. Y times negative 6 is negative 6y. We have negative 15. Negative 6 times plus negative 15 is negative 21. And negative 3 times negative 6 is a positive 18. And of course, if I bring my y across, it'll be 5y cubed. That was our first term up top. Negative 21y squared, that was our second term. And a positive 18y was our third term. Okay, let's see how we can do some more questions with this. Our next one, what if we have 35x squared minus 57x minus 44? How can we factor this one? Now again, first off, I'll look, and is there a GCF to this? There's no GCF. 35 is what? 1, 5, 7, 35. 7 doesn't go into 44, nor does 5, or not into 57 either. And so let's take a look at our AC method. What's 35 times 44? And so we have negative 1,000, negative 1,540. Now this is a large number, but let's go ahead and try to find two factors that will multiply up to negative 1,540 and add up to negative 57. Also looking at this is a negative number, so one has to be negative, one has to be positive, and the middle number is a negative number, so the larger of the two factors will have to be negative, and the smaller of the two will be positive. I'll pick, let's see, how about 20? Does 20 go into this? So if we look at 20, 20 goes into the 77 times. And again, the larger number should be negative. Negative 77 plus 20. Oh, good, that's a negative 57. So I found that number inside. Sometimes it's not as easy to find the pair of factors that will work. So again, using that method, x minus 77 and x plus 20. Take the coefficient of the x squared, which is 35, and divide both by this 35. And if I reduce 77 35ths, I see 5 goes into both of those. Sorry, 7 goes into both of those. 7 goes into the top 11 times. 7 goes in the bottom 5 times. And for 20 and 35, the factor would be 5. 5 goes into 24 times. Goes into 35 7 times. So we have 5x minus 11 and 7x plus 4. I always like to check my work. 5x times 7x is 35x squared. 20x minus 77x is negative 57x. and negative 11 or positive 4 is a negative 44. So good, we just factored that trinomial. Again, the first thing you should do is find and see if there's a GCF. So for number 6, we have this negative 16c squared minus 32c minus 7. First thing, we should find the GCF. 7 is a prime number, doesn't go into 32 nor 16. And so this can't be factored. But one thing I see is a c squared, there's a negative out in front. So let's go ahead and first factor out that negative in this term. So we'll have a positive, not x, go to c, 16c squared plus 32c plus the 7. So if I look at this, we have 16 and 7. 16 times 7 is 112, because I want to try to factor as far as possible. And let's take a look and see if there are two terms. I'll multiply up to 112 and add up to this 32. And of course we have 1 and 112. Let's see, 2 goes into this 56 times. That doesn't add up to 32. See, 3 does not go into it. 4 does though. 4 goes into it. 4 times 28 is 112. Oh, and look, that adds up to this 32. So these are my two numbers that we need with this. Okay, I'll bring down this negative. I'm just doing some scratch work right now. This is c plus 4 and c plus 28. We'll grab the coefficient of the c squared here and divide these both by 16. 4 and 16 can reduce as c plus 1/4. I'll bring this negative down here. And let's see, 4 goes into both of these. C goes into 28 7 times, goes into 16 4 times. And as we did in our previous examples, bring this 4 into this front of the c is the coefficient. Bring the 4 in front of the c. And you can check our work. 4c times 4c is 16c squared. There'll be a negative in there. 28c plus 4c is 32c. We want to multiply by negative 1 to be negative 32c. And 1 times 7 is negative 7. Well, it's positive 7, but the negative will make it negative 7. So this does work. And this is our final answer for this problem. Two more. Let's go two more and let's see how we can do this. Again, you can pause it, do it on your own, and see what we can do. But let's continue. For number 7 here, we can look at the GCF of 6x squared minus 4x minus 10. And since they're all even numbers, we know 2 goes into it, and that's the largest factor that will go into this trinomial. This would be 3x squared minus 2x minus 5. Let's see, are the two numbers I'll multiply? Well, let's multiply these two. 3 times negative 5 is negative 15. And now are there two numbers I'll multiply up to negative 15 and add up to negative 2. And let's see, the larger number should be negative. Oh, negative 5 and 3 will be our numbers here. So let's see, this would be x minus 5 times x plus 3. We'll divide by that 3x squared. This reduces down to 1. This does not reduce, so I'll put the coefficient of the 3 in front of the x. So for my final answer, I must bring this down this 2. So I'll write down here, this is 2 times 3x minus 5 times x plus 1. And remember, if you're going through the AC method here, and you don't find a pair of numbers that will multiply up to this AC product and add up to the middle terms, and this is going to be a prime polynomial, you cannot be factored. Let's try this last one. And this last one, I'll look at 2x squared, 5xy, and 2y. See, are there any common factors? There aren't any common factors. This one's a little bit trickier because there's an x squared over here and a y squared over here. So when we work with this, we'll need to have an x with a y in each of the binomials. But let's work with the same method. Is there any GCF of these three? And there's not. So I'll grab the a and I'll grab the c and multiply them together. 2 times positive 2 is 4. Are there two numbers that will break up, multiply up to 4 and add up to negative 5? And of course, negative 4 and negative 1 multiplies up to a positive 4 and adds up to negative 5. And make sure when you're factoring, you pay attention to the signs. there's some mistakes that are made with that. So when I work with this, we go x minus 4, and make sure you put the y with it this time. The last time we have the y squared, so we just had x minus 4, but we got to include it in this. And here we'll have x minus 1y, or x minus y. And again, what we'll do is we'll take a look at the coefficient of the x squared, or the first term, which is 2, and we'll divide these both by 2. We'll reduce this, so this will be x minus 2y, because 2 goes into 4 twice. And this one, 1 and 2, that's already reduced all the way, so we grab the 2, bring it in front of the x, and then we'll have 1y below here. So if I look at this, this is x times x squared, which is 2x squared. X times negative y is 1 negative xy. Negative 2y with positive 2x is a negative 4xy. And negative 2y minus times a negative y is a positive y squared. And so in checking my work here, yes, we'll have x squared, negative xy minus 4xy is a negative 5y, xy that is in the middle, and a plus 2xy, or 2y squared, sorry, is what we have out there. And so that is my factorization of this trinomial. Again, you can use this method, this AC method, dividing these terms by the coefficients and doing it that way, or there's the trial and error method. There's other methods you can use to do this. Well, good luck with this.